Dear students and viewers, please subscribe to my chemistry YouTube channel.
Hi, I'm your chemistry teacher. I'm Kamal. Welcome to my virtual online chemistry class. Today is my second lesson about mole. Already we have discussed what is mole. Let me revise it quickly. First of all, if somebody asks you what is mole, its answer is very simple. Mole is a number and its value is equal to Avogadro's particles, or Avogadro's particles may be atoms or molecules. Now, second definition of mole is mole as a mass. So mole as a mass is atomic mass or molecular mass expressed in grams. So these are some examples for the mole as mass. Our today's topic is about mole as a volume, which is my second lesson on mole. So mole as a volume is only for the gases. For the gases occupy different volumes at room temperature pressure or at standard temperature pressure. So let's see how we can express mole for the volume of the gas. So 1 mole of any gas at room temperature, which is RTP, occupies 24 dm cube, which is equal to 22.4 dm cube for STP, which is standard temperature pressure. Now there is a difference between these two values, and what is the reason? Let me tell you in the beginning. Reason is this: room temperature is considered 25 degrees Celsius. So at 25 degrees Celsius, 1 mole of any gas will occupy 24 dm cube, whereas the same volume will be reduced at low temperature, which is 20 degrees Celsius, according to standard temperature pressure, STP we say it. Now 1 mole of, for example, let's take the example, 1 mole of hydrogen gas occupies 24 dm cube at room temperature pressure, which is at 25 degrees Celsius, and it is equal to 22.4 dm cube at 20 degrees Celsius. Likewise, 1 mole of water, which is in the form of vapors or steam, will occupy 24 dm cube at 25 degrees Celsius at room temperature pressure conditions and 22.4 dm cube at standard temperature pressure conditions. My third example is 1 mole of oxygen will occupy 24 dm cube, again at 25 degrees Celsius, and this volume will be reduced when the temperature will be reduced. The reason is very simple. Gases expand on heating and contract on cooling. So this was the reason. So finally, let me conclude my second lesson as, if we say that 1 mole of water is equal to Avogadro's number of water molecules, which will be equal to this value, which is 6.022 to 10 raised to power 23 molecules, and this much molecules of water will sum up this much mass, which is 18 gram, and 18 gram of water as a vapor will occupy 24 dm cube at room temperature pressure and 22.4 dm cube at standard temperature pressure. No need to confuse. In different books, sometimes it's written 24 dm cube, and in some books it's written as 22.4 dm cube. But you have to be very conscious about the conditions which are given here. This is at room temperature and this is at standard temperature pressure. My last example is of oxygen. 1 mole of oxygen gas will occupy Avogadro's number of molecules, and this Avogadro's number of oxygen molecules will sum up with 32 gram. Its mass will be equal to this much molecules will occupy this much gram, which is molar mass. And if we take 32 gram of oxygen, this will occupy 24 dm cube of oxygen at room temperature pressure, and we may say 22.4 dm cube at standard temperature pressure. Thank you very much, class, for joining me. Stay safe, stay home.
Please subscribe to my chemistry YouTube channel.